Okay, welcome to the Turtle Time Trials tutorial video. Just kind of go over what this tutorial is going to be about, or this Desmos activity is going to be about. So in this lesson, students explore connections among different representations of proportional relationships with a glimpse at non-proportional relationships. Basically, we're just talking about slope right now. Um, the lesson centers around a race between turtles of different constant speeds. After encountering the context with an animation, students analyze and create other representations of the scenario. Number lines, graphs, tables, and equations. So if you can remember back to the first semester, we actually did a problem very similar to this. It was called the Big Race, where kids were riding tricycles and we had to graph their lines and see who won the race. And I think if I can remember, there was a clown in that race that participated in um, started at the finish line and rode backwards or something like that. So if you can remember that, great, because this is going to be very similar to that. If you can't, no worries. Um, just go ahead and get started, and just please read the directions very carefully, and just make sure that you're spending enough time on each slide to really understand what's going on. Okay, so for the first slide, right now it just says press play to watch a short animation and then write a story about what you see. So in these kind of like notice and wonder slides, I just want you to write as much as you can. I mean, and if you can kind of integrate some mathematical language in these explanations, then perfect. So right now, before we even get started on the video, you can write about, look, lane one turtle, this is the starting line. The lane one turtle is getting a head start. So we had the same kind of thing in the big race where a student that was riding a tricycle would get a head start, right? Now, if you can remember in our equation, a head start looked a certain way that had a certain um, thing attached to the equation, which we'll get to later on in the video or later on in the slides. So lane one gets a head start, lane two starts at the starting line. Let's see what happens. So you can pause these at any time. This one doesn't really give you a seconds, but at a certain point, lane two and lane one actually are pretty like not exactly, but right now they're at like the same spot on the little racetrack, right? So we can talk about that in here. Obviously, lane one is going much slower than lane two, even with the head start. Looks like lane two is going to win the race, which it does. So just say as much as you can in that slide right there. Okay, now here's where we get to more mathematical stuff. It says play to watch the turtles race. It's going to be the same exact race as we just watched, but now it's giving you time and distance. So right now, lane one at 0 seconds is about 5 feet from, well, it actually says 6 feet right here. We got a table, so it gives us actual measurements. Lane one starts at 6 feet from the starting line. Now lane two starts at 0, and in 1 second it's going to be at 3 feet. And if we play this and stop it right around 2 seconds, how far is it? It's pretty much, I mean, at 2 exactly. So, see here. 2 exactly, it's at 6 feet. So we put 6 feet, and then you need to kind of figure out what's going on here. So right now in a table, it's trying to get you to think about slope, speed, but then it's going to bring you to the connection between speed and slope. So keep on working on this. If you have a question, email me, but it shouldn't be that hard. Okay. Now, actually, yeah, I'll leave that there. So it says, because we can actually figure this out from here. Here's your table from the previous screen. What is the lane two turtle's speed? So feet per second. How many feet per 1 second is this lane two turtle traveling? Figure that out on your own. If you have questions, ask, but it should be pretty self-explanatory. So it's how many feet per 1 second? How many feet per 1 second? Okay, and now a new turtle enters the race in lane 3. Press play, watch the race, then continue the next screen. Okay, a lot of these, especially in my class, I really like um, note like first thing we do is just kind of see what happens, and then after that we're kind of like wondering, just writing down anything we can write about what just happened. So we're noticing and then wondering and then getting into the math side. So that's actually a really good habit to have um, in math class. So let's press play. Okay, so we had lane 3 jump in, and it looks like it's going maybe the same or a little bit slightly slower than lane 1. Definitely started at the start line, so it's way behind lane 1, so it doesn't actually catch up. And lane 2 is still faster than lane 1 and 3. All right, now, so we looked at tables. Now we're looking at lines. So the lines represent the information in the tables. We already have lane 2 and we already have lane 1. That's from the tables. Now there's a purple dot in a line right here. It says drag the point to represent the distance versus time relationship for the turtle in lane 3. Press play to check your work. Make sure you press play to check your work. And the hint right here is the turtle in lane 3 finishes the race in 8 seconds. So at 8 seconds, it's going to finish the race. Well, how long is the race? That right there, it's 12 feet, gives you a clue on where to drag this point. Finishes in 8 seconds, and it's 12 feet long. So right now, this is finishing in 8 seconds to get to 8 feet from the start line, but this is a 12 feet race, so you have to change this accordingly. I'm not going to give you the answer right now, but if you have questions, please email. And then it says, oh, to check my work. So let's actually check it. And this is obviously going to be wrong. Because look, we can see that it's wrong because this is the real turtle and this is the turtle that we graphed. So we can actually speed it up while the video is playing. So this is way too slow. Let's go back. This would be too fast because this is the real turtle, the kind of hidden one. So you got to kind of play with it, use that, but use the advice I gave you with the 8 and 12. Okay, says this graph shows the relationship between distance and time for the turtles. Which is faster, lane 1 turtle or lane 3 turtle? You can pretty much do this one on your own, but the steeper the line, the faster the turtle. Okay, so now we're used to writing our equations in y equals x plus 5 or something like that. Now these equations are almost the exact same thing, except for instead of a y we have a d, instead of an x we have a t, because it's distance in time instead of y in x. It's distance in time. Same exact equations though. Like they operate the same, just different letters. And these are probably actually a little bit more easier for you guys to understand because it's distance in time, d as in distance, t as in time. So new turtle enters the race in lane 4. Write an equation for the new turtle and press play. Okay, so you can write anything. And if you write y equals x plus 5, it won't work. So you need to write d equals something time. So 3 is the slope, the speed, 3 feet per second, plus, let's say, 2, right? So it's at a 2 feet head start, 2 foot head start, and then 3 feet per second speed. So let's see what happens. Boom, first place. Okay, now in the video, or in the Google form, I actually did this. So I put this, oh, actually, no, that's wrong. It's supposed to be 78. Here, let me. So if you're watching this video, you're going to get a free answer to the Google form question. Now, right now, and here's the answer. So kudos to you for watching these. 78 is feet per second. So this turtle in lane 4 is traveling at 78 feet per second. And negative 300 means that it's negative 300 feet behind the starting line. Let's see what happens. And there's a trick in the Google form reflections. Let's see what happens if I use this equation. Who will win? What do you think? With 78 feet per second starting 300 feet behind the start line. Right here is where I took a screenshot of the race at 3.9 seconds. Oh, it looks like blue's gonna win, but let's see. Oh, nope, tie. So I played around with that enough to make them tie and then try to trick some people. Anyways, so kudos to you for watching this. Thank you. And then it says create your own turtle race by sketching the graphs of 4 turtles. So you can get crazy with this. There are 4 different colors representing the 4 different turtle races. Now you can do very simple stuff like that, just a straight red line. If you play it, then that turtle will travel that quickly for the race. So the steeper the line, here's this very steep line. Steeper the line, let's play it, the faster it goes. But what you could do is you can do some crazy stuff. So you could do, maybe my turtle travels that fast at that time and then goes really, really slow. So watch this. Really fast, and then at that, that's 3 seconds and it travels really slow. Or maybe you want a turtle race that your turtle goes backwards in your race. It's traveling backwards, oh my gosh. So make some cool stuff in here, save it, and then I'm gonna start looking at kind of what you guys create in this. And then it just answers some questions about the graphs in here, and that's it. And you should be able to answer these. I'll check and see if you got these completely wrong and contact you if you're just totally lost. And that is it for my screencast.